Hey guys, everyone, welcome to this Wintellect webinar. I'm Blaze Stewart. I'm going to be hosting today's webinar, and today we're going to be looking at all the different kinds of messaging services on Azure. Now, again, I don't claim that this is an exhaustive list, but we're going to try to tackle most of the common ones that you're going to see in application development and ones that are commonly used, even just in the context of just getting stuff up and running on Azure. So with all that, let's just dive right in and start talking about all these different messaging. So this with a little bit of housekeeping though, there is a question and answer session at the end of this. So if you have questions about anything I've said, or you just are kind of looking for some pointers on when you might want to use one or the other, there's a question feature as part of GoToWebinar. You can put your questions there and I'll read those questions at the end and respond to them as they come through to that. And also this session will be recorded and we'll put it up on our YouTube channel so that you can watch it there, so that you can review the information that we present here. So with no further ado, I'm going to talk about me, talk about Atmosera, and then we'll go right into talking about all these various things. My name is Blaze Stewart. I am an architect at Atmosera. I work with Azure clients and helping them get their workloads running up on Azure. I typically focus on apps that are on-premise and migrating those to Azure, or creating apps in Azure, and working on data workloads, as well as working with app infrastructure on Azure as well. So I tend to focus on app-focused workloads, not so much in the AI side of things or things in that, or around security and those other things, but we do have folks at Atmosera that do that. I'm a Microsoft Azure MVP, so I work a lot in the Azure space and also do a lot of content development as well. About Atmosera, we are a top tier partner with Microsoft in that we practically touch almost everything that Microsoft does related to Azure. So you can see here that we've got a lot of competencies in learning, DevOps, data platform, application development, cloud platform, productivity, data analytics, security, et cetera, et cetera, et cetera. We really like to focus on Azure. That's kind of our main thing. So we are both consulting, we do managed services, and we do a lot of on instructor-led training as well as on-demand training for all things related to the Microsoft stack, specifically around Azure. And so that is really what I like to focus on. I kind of stripe across a lot of these different organizations and working with consulting, training, and sometimes getting involved with some of the managed services stuff as well. Also, we are a GitHub verified partner, which means that we partner with GitHub to help bridge the gap between GitHub and DevOps into Azure, as well as just in general on how you might use that for your development needs. So with that, let's go right into the content here. And we're going to be looking at a bunch of different messaging platforms on Azure, and they're not in any particular order. But I wanted to start with the first one, which is going to be the sorry, not the first one, but just kind of an architecture of what I'm going to be doing later in the video or in the webinar related to an architecture that is going to be for my demo. And I wanted to show you this first to give you some context to really what it is that I'm trying to drive home with this whole thing. Now, on this particular demo architecture, which we'll unpack as I actually show you all of these various things in action, is that messaging on Azure really isn't this versus this. It's really kind of a nexus of different kinds of messaging. So understanding how they all work and how they all kind of fit together helps build out a more total platform that you might need for a given application. The bottom line is that there's really no one messaging platform on Azure that does everything well. So really what you gotta have to do is try to figure out which ones are gonna be useful for your use cases. Some of these are very specific, such as IoT Hub. That's gonna be specifically built for IoT workloads. However, you have things like event hubs and service bus, which are kind of similar, but they're also different in some respects too. And then you'll see things like storage queues and service bus. They have some similarities, but they're different, and they have different kinds of use cases associated with them. So the idea of this is not to try to convince you that one of these is going to be the one thing that solves all your problems, but it's really try to do, show you how each one of these works in their own context, as well as how they kind of fit together so that you can build out a solution that's going to serve the need of whatever it is you're trying to build on Azure. So this is, again, not to try to convince you that you should use Service Bus for everything or you shouldn't use Service Bus for anything. It's really to say, hey, in these use cases, Service Bus makes sense. In these certain use cases, Event Hub makes sense. In these use cases, storage queues might even make sense. So let's try to keep that in the back of your mind. And then ultimately, when I show you this, hopefully you'll get an idea of like how you can kind of glue some of this together to get different kinds of behaviors out of the messaging on Azure. So let's go over here and talk about the first one, which is, I'm going to start with Service Bus, just because that's kind of the most common one that most people are familiar with whenever we start to think about messaging on Azure. So the first one is going to be Service Bus queues. Now, Service Bus queues is a fairly common understanding. Most folks get this. This is a very common pattern that folks see in multiple different kinds of implementations, whether it be Service Bus on Azure, or you're using something like RabbitMQ or an MQTT server like Mosquito or something like that. A queue is a very simple asynchronous development pattern where you have producers and you have consumers, and the producers just basically create messages, put them on a queue, and then this consumer over here reads from the queue and processes the messages. And so this is an asynchronous pattern. It's good for doing a lot of things about breaking up these producers from the consumer so they're not directly talking to one another, so you don't have breakdowns in communication. So queues allow you to have asynchronous communication between these. So in the event that maybe the consumer goes down, you can still queue messages up and then ultimately have the consumer come back online and produce the read that queue and then ultimately process the messages. And it also scales well too, because you can have actually multiple consumers on a queue that are popping messages off the queue and then processing those in parallel. And so this allows for scalability as well without having to create like a load balancer. Rather, it's just kind of inherently load balanced by the fact that you have multiple consumers over here that are reading from the same queue and then processing those messages in parallel with one another. So that's one way that queues are often used. But the basic idea is pretty straightforward, where you have basically one message that's on queued by a producer, and then that message is read at least once by a consumer, and then it's processed and then removed from the queue. So that's pretty straightforward. Now, where this gets a little bit more interesting is with topics. Now, topics, again, are a fairly common thing on Azure, and as well as any other messaging platform. So you're going to see this in something like Mosquito, or if you're using another messaging platform like RabbitMQ or what have you, they do support topics. Now, the real advantage of topics, though, is that you can get a single subscriber for any given message. So this allows you to have each individual subscriber to have its own copy of the message, and it processes that message independent of all of the other subscribers that are also receiving that exact same message. So you'll have a bunch of producers. You'll have topics like this. It's essentially a queue in many ways, and then the topic will then create a copy of that message for each of the various consumers that are going to be getting that. Now, one thing I like about Service Bus, and you excuse me, and other things that you can do with this is it gives you some the ability to create automatic forwarders and filters for subscriptions, which is a really nice feature, because what that allows you to do is have the Service Bus filter out messages that go into a given subscription. So maybe it only wants to listen to messages from a specific producer or a specific set of producers and ignore all the other ones. And so you can do things like filtering with Service Bus topics. And so it will only see a subset of everything that actually comes into the topic, and it will only process those accordingly. And the same thing would be going over here if this one was only receiving a subset of those messages that were coming into this subscription. So you can kind of split the workload out based on filtering that happens on the Service Bus. So that's a really nice feature about what this is able to do. And then, as I mentioned, automatic forwarding is something that allows you to basically move messages from topics to queues and queues to topics, so that I can send a message into a topic, filter that message, and then if I want to, on a given subscription, forward that message back to another topic or another queue automatically, so that you can get some kind of routes going on inside of your Service Bus that are automatically done just by virtue of configuring the Service Bus. And so combining queues and topics and filters on a service bus really gives you some really dynamic content and different ways of processing things on Azure. So Service Bus is one of the most common ones, and I wanted to start here because it's kind of the basic pattern that is going to be implemented by many of the other ones that we're going to talk about in this webinar. It actually serves as the basis for at least 3 other services that we're going to look at. So it's, again, the most fundamental one. It's probably the most general purpose one as well, because it exposes all those features that we just talked about in brief with filters and forwarders and all that kind of thing. But what you can also do with Service Bus is add stuff on top of it that is more what we call value added services that some of the other more point solutions add to Service Bus to round it out to make it more tailored for specific applications, such as IoT Hub or Event Hubs or things like that. So Service Bus, again, is going to be very relevant to all of the conversation that we're going to be talking about throughout the webinar, with the exception of, like storage queues. But in any case, this one I wanted to mention first for that reason. Now, with that in mind, I do want to mention storage queues, because storage queues have a special place in my heart, because I like these for a lot of reasons. One of the reasons I like storage queues is they're just simple. And again, Service Bus queues have their place. I generally like to start with storage queues on a lot of projects because storage queues are very inexpensive, and for many applications, they're going to be good enough in terms of performance and latency and all the other kinds of things that come with it that are going to work for most applications. But you still have the ability to do asynchronous patterns that you would still get with something like Service Bus, and storage queues give you that multiple producer into a single queue with a consumer on the other end that's looking for new messages that come onto the queue. The biggest difference between Service Bus and this particular implementation is with Service Bus queues and topics, for that matter, it's pretty much real time from when a message lands on the queue, and if there's an active subscription, an active client connected to that queue or that topic, the message is automatically sent on by way of the Service Bus. It's more of a push style architecture from the queue. So it gets on the queue. If there's a client, it just starts sending it to that client as fast as the client can consume those. While with a storage queue, it requires that the client poll the queue for new messages as they come onto the queue. So you have to create a polling instance inside your application to go out there, look for new messages, and then check it periodically. So every 1 second, every 2 seconds. I typically build a back off loop with storage queues just because I don't want to sit there and pull it incessantly whenever there's really nothing going to it. But if it's doing something like on a 1 second interval, then I will restart the timer. So I get a new message, process that message, and then I'll go it and then I'll reset it to 1 second again, and then it will continue to poll on a 1 second interval until there's nothing there. Then it will start 1 second, 2 seconds, 4 seconds, and so on, and it will start that back off loop. So it's just not polling that when there's just nothing there. So you might end up with latency here that's introduced by polling. But if that's acceptable for your application, storage queues can be a really nice solution for many things in the way of building out queues like you would do inside of Service Bus. And that is probably why I start with these, just because it's simple. They scale up to a point, but if my demand exceeds what a storage queue can do, then I'll go to something like Service Bus, or there's a feature of Service Bus that I want to use, such as topics with the filter that queuing wouldn't do. And so that becomes a little bit harder to rationalize when I'm using storage queues for those reasons. So again, storage queues, default to that if that's something that you are thinking about. And if it doesn't work, it's really easy to change an application from using storage queues to using something like Service Bus, and vice versa. You can pretty much swap the two out with very little pain points if your application is well factored, that is. You can generally abstract it away and even use the same interfaces for getting new messages and also publishing messages to these things in your application, and then just use some kind of implementation of that interface in your application and swap that out if you want to use storage queues in some instances and service bus queues and another one. So again, very easy to implement, very easy to use. I like these for a lot of reasons for that reason. So let's go and talk about the next one, which is going to be Event Hub. Now, I talked about storage queues to mention those, and I've talked about service bus queues and service bus topics to try to talk about some of these more point solutions now, which Event Hub is one of those. It's based on service bus. Under the hood, Event Hub is based on service bus, and Event Hub works a lot like queues do. So if you actually implement this, you'll say, what's the difference between this and something like service bus? Most of it is not so much architecturally as much as it is intent. And so the intent of Event Hub versus something like a service bus is this right here, and that's real-time processing. Real-time processing in the context of Event Hub is designed to stream messages from producers. So you have all of these producers over here that are producing messages. I mean, you could get thousands of producers of messages and then scale that exponentially, and you end up with potentially millions of messages flowing into an Event Hub. And this is designed to basically take a whole mass of messages coming into a given endpoint and stream those messages through some kind of real-time processing, such as an Azure function, SQL Stream Analytics, or Kafka, or something like that, that is oriented around real-time analytics of data. So the canonical use case for this in Azure is Azure Stream Analytics, which basically gives you a SQL-like syntax, which allows you to look at messages and query those messages. And you can also aggregate it with static data as well. But it allows you to massage, transform, enrich, do that kind of data enrichment. And then you can take the output from that, put it into some kind of cold storage, or update a dashboard, or send it to an Event Hub or another Event Hub, or another. You can also send it to another service bus if you want to. The main thing to remember with this is that this doesn't really have persistence to it. I mean, you can configure message retention on this, but the intention of this is not to keep messages on the Event Hub. It's designed to stream messages through it. So it's not about retaining messages. If you want to retain messages for a period of time, use service bus, use storage queues. But Event Hub is not designed for long-term message retention. By long-term, I mean more than a few minutes or more than a day maybe. But really, you don't even want to keep these on there for that long. You really want to get them on there and get them off the Event Hub as quickly as you can. If you need message retention and you need to be able to queue these up over a period of time, and you want to be able to have that kind of retention built into the platform, think about using something like service bus or storage queues for that, and don't use Event Hubs. So try to keep that in mind. And you do have the idea of cold storage in Event Hubs. It is configurable so that you can persist messages that come into your Event Hub to something like a data lake or a storage account. And the cold storage there is to provide an archive of things that have happened, but also it's designed to allow you to do replays for debugging. So if you need to go back and reload a bunch of messages in from that cold storage, you can basically put those back onto the Event Hub without actually having to have the producer reproduce all of those messages. And you can replay those messages through the Event Hub and then have the real-time processor process them as they come through. So that's good for development purposes and debugging purposes as well. Cold storage is there for that. And it can also serve as a way for more batch-oriented workloads if you want to do that. So you can pump everything into your Event Hub, put it in cold storage, and then you could have something like Azure Data Factory operate on those messages, as well as do real-time stream analytics using something like Azure Stream Analytics, Kafka, or an Azure function, or something like that. So you have this option here. But the main thing here to keep in mind with Event Hubs is real time. That's the real gist, and that's the real differentiator between this and Service Bus. So let's talk about the next one. IoT Hub. This is another one of those point solutions that is oriented around a specific kind of workload. My throat is kind of bothering me a little bit, so I had to take a swallow there. In any case, IoT Hub is another point solution similar to what, not similar to Event Hub, but it is a point solution that's designed for something that's in mind. And then obviously it's IoT. So IoT in the context of messaging is where you have tons of devices, and devices are going to be connected to the internet, and you need a way to kind of bring all those devices into a single unified platform for management and communication, so that they're not just out there trying to communicate with something that is not orchestrated in any way. So device orchestration combined with device communication is really what IoT is all about, and IoT Hub in particular. So IoT Hub is again built on top of Service Bus, but it adds a lot of other features that are going to work with IoT's workloads. And you have this concept of cloud to device messaging. So it provides basically a two-way communication by way of Service Bus for sending messages from the cloud down to the device, and that's brokered by Service Bus through a queue, and vice versa. You have a device to cloud message where you have a device that's sending a message from the device up to the cloud, and that's actually under the hood using a topic, and you can have multiple subscribers to that topic. In any case, this is brokered by Service Bus under the hood, but it's still a two-way street for bidirectional communication from the device. Most of the communication is generally going to be device to cloud messaging, wherein you have a IoT device that is just sending telemetry up to the cloud. And that telemetry could be sensor data. So it's measuring barometric pressure, it's measuring temperature, it's measuring precipitation. Maybe it's capturing footage, maybe it's taking photographs. Well, I don't know. There's all kinds of sensors that you can have, and it's collecting all that data, and it's basically just funneling all that data through IoT Hub. IoT Hub also has a lot of other features for managing devices, for managing device life cycles, for uploading files, and a lot of other things that are specific to IoT workloads we're not going to get into. But again, that's all brokered through messaging to and from the cloud by Service Bus behind the scenes there. And so ultimately, what you have on the other side of IoT Hub is going to be some other kind of messaging platform. So IoT Hub is designed for getting messages from the device to the cloud. And once they're on the cloud, IoT Hub wants to do something with that message. It doesn't want to retain it. It wants to send that on to something else. So it's going to send it on probably to a Service Bus or an Event Hub, or it can persist it in something like storage or something like that. So that's why you kind of have this client over here that's kind of sending messages from this client over here down to the device, and then also receiving them up from the IoT Hub as well. And it's also going to interact with blob storage, which it's kind of outside the scope of messaging in this context, but you still get the interaction between IoT Hub in that regard. But again, fundamentally, it's running on Service Bus, and that's what you want to take away. So my demo is really going to start with IoT Hub whenever you look at this later on, and we're going to see how it's connected to both a Service Bus and an Event Hub, and it's going to use both of those. So the other one, these last few that I'm going to be looking at here are going to be oriented around the kind of messaging that you can do that is going to be interacting with clients. And the clients kind of messaging are application style messaging. By that, I'm talking about push notifications and that kind of thing. And that's what the next, essentially the next two I'm going to be talking about. And you could probably, the third one would be that as well. And Notification Hub is one of those that we're talking about here. So a Notification Hub is basically an abstraction around, fundamentally under the hood is running a Service Bus, but it's basically providing an abstraction to get notifications to mobile devices or to Windows devices. So if you think about a push notifications on iOS or Android, or back in the day, Windows Phone, or even in Windows itself, you have the ability to register an application inside of whatever platform portal that you're going to be using. In the case of Android, you go to Firebase. If in Azure, in iOS, you go to APN. And these platforms allow you to register your app with that particular notification provider, because what they don't want you to have on every device is a daemon out there that's listening for push notifications for every app that you have installed on your device. And that could get rather arduous and drain your battery and so many other things that's not good for mobile devices. So the platform providers, in an attempt to mitigate that, have kind of created a platform to consolidate that use case. And then what you are allowed to do is take your app, register it with that provider, whether it be APN or Firebase, or there's a couple other ones that I don't have listed here that are geographic specific. But this allows you to say, my app is going to receive push notifications. I register my app, and then your user essentially consents to receive push notifications from that particular provider. Now, what Notification Hub does is it basically unifies the platform, is a unified platform for doing this across multiple device-specific platforms. So iOS has theirs, Android has theirs, etc. But Notification Hub allows you to have a single point to send a message to, and then what it will do is it will then interface with APN and Firebase and all these other ones, and then forward those messages onto those providers, and then the providers will then ultimately send that on to the actual mobile app that is going to be running, or the device really, and then the device then can respond appropriately to those push notifications that are coming from a Notification Hub. Now, this is typically done in the context of an app server that you're going to have running on Azure already. So you might have an app service that is going to be running some kind of ASP.NET application, and then it's going to interact with Notification Hub that then can send on to APN and Firebase, and then send that on to iOS and Android devices. So that's a client-facing implementation of messaging from the cloud to devices. But this is not IoT, but this is for mobile application development, and this is designed specifically for that one. And the next one is similar in that respect, but it is not really designed for push notifications as it is for two-way communications in web applications, or at least that was its original intent. And this is Signalr Service. Now, originally, Signalr was developed back in the old days of .NET to provide not asynchronous, but bidirectional communication between web apps that were browser-based and application servers. And the way that was typically done was through long polling. Well, when WebSockets came out, the ability to use WebSockets for bidirectional communication meant that you had to write essentially two different stacks. You had to write either a long polling implementation or something that was based on WebSockets. So to kind of mitigate that on the client and the server side, Microsoft introduced Signalr that basically provided a abstraction and an interface that would implement both a long polling model and a bidirectional communication over WebSockets that allowed you to do bidirectional communication. So the server could push messages to the client, and the client could send messages back to the server without having to do HTTP requests and response type requests, or at least it could fake it through long polling in that regard. But the interfaces were identical on both ends of the wire. So that was a really an advancement in application development for web apps, which were typically, prior to that, restricted to request response type workloads that were HTTP based. Well, then along came the cloud, and with the cloud, doing this in something like app services became not possible. It didn't support it because app services was oriented around this request response model that was HTTP based, and so it didn't have any way to really do meaningfully do Signalr through WebSockets at that point. So to kind of get away from that, Microsoft introduced the Signalr Service, which is a messaging service that allows app services to implement Signalr without actually having implemented it in their code to act as that provider right here. Instead, it allows an abstraction. So the broker of this will then send this as an endpoint for the Signalr communication. That's the Signalr service. And now the application, after it connects to the app service, can then do bidirectional communication with the app service by way of a Signalr service in the background. And so that allows for Signalr applications to exist on Azure without actually having to implement that either by using a virtual machine or not having it at all in something like an Azure App Service implementation at that point. So that is why this exists. And it is a messaging platform that you can connect up to other messaging platforms and send essentially cloud messages from the app servers down to your apps that are running in something like a browser. So if you wanted to say take something like a service bus, you could wire up a service bus to use Signalr to update a dashboard that's running inside of a web client using Signalr. And so that's really what this is getting at. So that's kind of what makes this a client-focused messaging platform, but it would integrate with something like a backend service, something like Service Bus, or something like that. However, it is possible to connect Service Bus up to a web client now, and you can do that. However, Signalr just gives you a lot of libraries that provide the abstraction that make it a lot easier to do in that regard. So the last one I want to talk about is Sendgrid. And Sendgrid is designed for messaging, sending email messages specifically. And again, a client-focused messaging platform here. And this one is not really Azure specific. This is actually a service provider by, it was originally its own thing, but Twilio bought Sendgrid recently, but it works kind of as a third-party solution that feels like a first-party solution in Azure in many ways, because the billing is integrated with Azure, and it's usually preferred to use Sendgrid instead of just a homegrown SMTP server for doing messaging on Azure. And so you can create a Sendgrid subscription and it'd be billed to your Azure subscription, although it's actually brokered by Twilio for messaging. And so what Sendgrid allows you to do is have essentially a way to send email at scale and do it in a way that is trusted and secure. And the preferred way is obviously to use an API, but this basically gives you the ability to have the app server send a message through Sendgrid, and then it will get sent to an email server, and then ultimately to an email client. And this is commonly used for sending out reports, for doing password resets, for B2 customer, B2C communication. So it's got a lot of features around marketing and contract, basically for a customer journey type features that you would expect to find in something like a CRM system or something like that. But this one does have a very rich API. It has a templating engine. It's got a lot of features about it that really do make it a very soup to nuts kind of email solution, not just for marketing purposes, but also just for application integration purposes as well, because it does have a rich API for sending messages through. And it does provide connectors for things like Azure Functions and Logic Apps and some of the other integration suites that exist on Azure that you can use for wiring up things to send email. And that's how I'm going to be using it in my demo, is basically just to send an email message. But that's, again, it scales well and it's got a lot of really cool features, but it's a client-facing messaging platform in that regard. So that's a brief overview of the platforms I wanted to look at for that. The main one that just to kind of recap, we looked at Service Bus, we looked at queues and topics in that regard. We looked at storage queues, event hubs, IoT hub, notification hub. There's a lot of hubs there. The Signalr Service. We looked at Sendgrid, and we've looked at just a lot of the various features that are when you might want to use one and when you might want to use another. Now, go back to the slide that we looked at first, and this is the demo that I want to talk about here. Now that we kind of talked through those various kinds of messaging platforms, I wanted to look at these through kind of an extended demo. And when I originally started to develop this content for this particular webinar, I had started to develop a lot of just demos, one-off demos for each one of these. And it kind of occurred to me that that's really realistically not how these work. And the reason why is because of what we're looking at here. Typically with any one of these messaging platforms, you're going to end up integrating it with something else. And you, generally speaking, might have at least 2, maybe 3 or 4 of these present in any one of these applications. Now, in this one, I tried to get as many as I could. I mean, without going overboard. But the reality is that's probably what's going to happen. So what I did is I created an IoT device to interact with IoT Hub. And then I wired up IoT Hub to take telemetry messages from an IoT device and send that to Service Bus. And it also sends it to Event Hub. Now, Event Hub, I have an Event Hub client over here that's running. It's just a daemon that's running, that's just listening for Event Hub messages to come through. But, you know, as I said with Event Hub, you can also persist those messages right here. And so another one I didn't talk about is Event Grid. And did I have a slide for that? I did not include that. That's I should have included that. I don't have a. I do have one. It's just misnamed here. Sorry. Pardon me for this. This should be named Event Grid. This is the wrong title for the slide. This is an Event Grid slide here. Event Grid is another messaging platform on this, and it's again built on Service Bus, but it is a point solution for dealing with events that happen in the context of Azure. And basically what you can do with this one is what you have with Event Grid is something happens on Azure, and you need to know about that. And what you have with Event Grid is a new blob was created. There was a new user created in Azure Active Directory. I have a something that's happening inside of a storage account that I want to know about. There's something that's happening on a virtual machine that I want to know about. These are all events on Azure. And so Event Grid basically can let you know that these things happen in the Azure context. So what you end up doing is you create something that looks very much like a Service Bus topic. And that Service Bus topic then will allow you to create subscriptions that are going to be one of many different kinds of subscriptions to that given event topic on Azure. So the canonical use case that I like to talk about is I want to know when a new blob hits a storage account, and that new blob is created, and I want to know about that. Now, you could create an Azure function to do that. There's a notification or a trigger in Azure Functions that can respond to an event on blob storage. However, if I wanted to get something like a Service Bus to respond to that event, I can do that. What I do in that case is I create an Event Grid topic and I wire it up to something like a storage account. And I say, I only want to know when a new blob is created. And then I set up a subscription to a Service Bus in that regard. And that Service Bus then gets notified when a new blob hits blob storage. Now, that's not something you can do natively with Service Bus. However, if I use an Event Grid topic, I can do that with Service Bus because this is going to broker that event right here that happens in Azure with that Service Bus subscription. Now, of course, you can put that onto other things like storage queues or Event Hub or whatever it might be. But you can then integrate all of those events that are happening in those contexts with other types of messaging platforms on Azure. And that's really what this is trying to get at. And that's what Event Grid is for. And so that's why it's on this particular slide here. So to get back to what I was talking about a minute ago with IoT Hub, I'm initiating everything with my IoT Hub here. Now, my IoT device over here basically does it's a motion detector. And what it does is when it detects motion, what it's going to do is it's going to upload a file to blob storage, and then it's going to notify Azure IoT Hub that there is a new motion capture. And so that message comes from the device over to IoT Hub. IoT Hub is then going to forward that message onto Service Bus and Event Hub. And then Event Hub is going to listen for that. I have an Event Hub client over here that's going to listen for that message as it comes off the device. And so is Service Bus for that matter. Now, remember what I said about Event Hub is I can persist messages into cold storage, blob storage. And so what I have down here in this case is those messages going into blob storage, as well as the recordings that the motion capture device is writing to blob storage as well. And because I have an event grid topic listening to that blob storage account, I can create subscriptions to that event on the blob storage, and that gets sent up to service bus and over to storage queues. So I have two subscriptions over here to my event grid topic, and one of them is going to service bus. And so that again is getting emailed out just like the event hub telemetry is. And so if this motion capture works, I'm essentially going to get three different messages. I'm going to get one saying the original message that came in through IoT Hub that the service bus got forwarded. The second one is the Event Hub message that gets persisted to cold storage that the Event Hub triggers, gets sent over to the service bus and emailed to me. And then the third one is going to be the actual message about the new payload that came in through the file upload into blob storage by way of event grid topics into service bus and over here into my email client. Now, my Event Hub client right here is only going to get the telemetry message right here. It's not going to get the message that's coming in from the storage account because there's nothing that's forwarding it over there. But my storage queue will get the both the notification that there's something new in the blob storage account and the Event Hub message, because the Event Hub wrote it to blob storage, and now that my event grid topic is sending that to a storage queue, and then that's my storage queue client over here that's going to read that. So basically what I have here is three different clients that are all kind of responding to these different message flows, and they're all wired together in different ways. And so I have this Event Hub, all this kind of flowing here. So that's my demo architecture, and this is to kind of show you how all this works. Now, I wired up all of this stuff in this yellow box here. This represents Azure right here. And Sendgrid is kind of off Azure, but you can kind of consider it as part of Azure in a way. I wired up all of this stuff in Azure using no code. I just basically configured Azure to do all this for me. Now, I did use Logic Apps, which is, I needed that to listen to Service Bus and do something on Sendgrid because there was no native integration here. But again, that's no code. That's just a workflow designer. And so I wired it up to Service Bus, and then I took the Sendgrid provider in Logic Apps to forward that message onto Sendgrid, and it just basically processes. I could have done the same thing in the function app or something like that. But the rest of this, I just wired it up just basically by configuring Azure to do all this stuff. Now, of course, I do have code over here in my clients because I had to write those clients right here. Those are just daemons. I wrote those in .NET. No, I wrote those in Node.js. But this is an email client right here. So that's just, I have a Gmail account. It's just going to send it to Gmail. So let's run this demo and let's see what happens. So if all goes well, I should be able to see email messages, Event Hub messages, and storage queue messages all responding to the same stuff that's happening over here in this IoT device by all this plumbing that exists over here. So let's get out of the slide deck here and let's pull up my IoT Hub here. Now, this is my IoT Hub here. Now, I have my device right here. This is my device. I'm SSH'd into it. This is my device right here. And this is just a simple development device that I have that's got a camera connected to it. And the camera, once I turn the camera on, the camera will start doing motion capture. And so my camera is sitting kind of off to my left over here, so you can't see that on screen. But if I wave my hand in front of it, it's going to start capturing motion. Now, it will record a video over, I think, a period of about a minute or 15 seconds, and then upload that or if I kill it before then I terminate the process, it will, or terminate the capture, it will then upload what it did record and then send a message on that way. So to do this, I'm going to do a cloud to device message to turn the camera on. So I'm going to initiate that by way of IoT Hub. I'm going to come down here into my devices, and I'm going to do a device to cloud message, or what they call a direct method in this case. It's a special kind of cloud to device message. I'm going to call it, and it's called turn on camera. If I could spell camera right. And this basically is just going to invoke a message, send that down to the device, and it's going to turn on the camera. And if all goes well, I should see the LED come on here, and it did. And I'm going to wave my arm around in front of the camera, and let's see if I can get my IoT device up here. And we can see that it did turn on the capture feature, and now that it's recording off the camera, and I'm waving my hand down in front of it. So it's actually recording a video because it's detecting motion. Now I'm going to turn the camera off just so that I can expedite this demo a little bit. Turn off camera, and it'll upload the difference. It'll just take the video that I recorded and upload it to the web. So I'm going to do another cloud to device message by way of a direct method, and it's going to turn off the camera. The LED did go off on the camera. I see that happen, and there's the message. And you see that it's got a new motion capture right here. And so that is now uploading that to blob storage. So part of the automation of the device, as brokered by this particular IoT hub, is that it's a request, basically an endpoint to upload a message, endpoint to upload something to, and then it uploads that file to blob storage. Now, once it uploads the recording to blob storage, it sends a message. And so this queued up a message and sent it over to Azure IoT Hub. Now, Azure IoT Hub in this case, if I look at my routes here, if I come down here to I'm back in my devices here. Let me pull up my, where is it? Message routing. There it is. I can see that I have it. I'm sending it over to device messages. I'm sending it over to an event hub, and I'm sending it over to a service bus. And this one, if I look at the configuration of it, I would see that it's sending it over to a service bus, and that's why I called it -EH. That's for an event hub. And this one is sending it to a service bus right here, and that is where it's going to forward that message on to. Now, if I come back over here to my resource group where I have all these resources, I have a event hub right here, and I hear the service bus that it's using right here. And these are the various things that are receiving the messages from the IoT hub. And if I pull this up, we should be able to see some recent telemetry, one message that just came through, and that's what I expect. That's because I have a event hub down here that just recently captured that event and then forwarded it on, that it persisted that message to the cold storage, and it then, I have a client that should be waiting on it. Actually, I didn't start the clients here, so let me start my subscriber for my event hub. And this should pick up a message from that. So if I go node index.js, that should pick up a message. No, it's not. It's not going to pick up that message because Event Hub needs to be alive. If I do it for my other one, my storage queue option here, oh yeah, it did. It just took a minute. There it is right there. That's the message that came through on the Event Hub. Now, I have another subscriber, which is this is storage queue subscriber that we'll look at in just a second. But the storage queue is getting messages from the Event Hub, and it's also getting messages from the fact that I sent something up to blob storage by way of a file upload from the IoT device. So that again is brokered by the event grid topic right here. If I go into my event grid topic right here, you will see you can see that I have 2 subscriptions to this particular event grid topic, and this event grid topic is listening to changes on my storage account. And so a new blob goes out to storage queue, and this is a new file, and that one goes storage queue. That one goes out to storage queue, and this one goes out to a service bus queue. And so both of those are subscribed to this event. And so I should see the fact that I uploaded that video to blob storage, go to my service bus, and then ultimately down to Sendgrid, and then also my storage queue client as well. So let's go look at the storage queue real quick, and then we'll go and look at the service bus as well. So I have a storage queue here in a storage account, and it's right here. And if I go into this storage account right here, and I look at my queues, this is the new file queue right here. And you should see some messages on here because I have not started the client yet. So these are the two things that got uploaded to blob storage. One was from the Event Hub because it persisted the message, and one was the original video that I uploaded. And so both of those are sitting out there in the queue waiting for me to start my my storage queue client, which I'll go ahead and do that now just so that we can see that in action. So let me go ahead and start Node.js index.js here. And those are both those messages that we just saw right here. And there's my backoff loop that I mentioned earlier. And so this one works just fine for kind of that low threshold, doesn't care about latency type messaging. But again, it's a queue. it works just the same way as most other queues do. Now, let's go and look at the service bus too. This received messages from the event grid topic as well as the IoT hub. Remember, that's what we were talking about there. So if I go over here to my service bus, I have a queue set up here. And my queue has a new file queue here. And I already have a client that's listening to this, and that's that Logic app. So there's not going to be any messages on this queue right now. But the Logic app that I have is listening to this queue. And so it's the receiver of this queue. It's the consumer of the messages, while the publisher was the IoT hub as well as the event grid topic that were both publishing messages to this particular queue right here. And then if we go back, I have a Logic app here that is then kind of taking all of those messages and just creating an email message and then forwarding that onto Sendgrid downstream of it. And so this particular, if I go over here and look at my workflow, this is the workflow that I designed for this. And again, no code here, nothing real high tech. It's just basically something that says when something is available on the queue, send a message. Oh, so you got to do a for each loop because it can actually get multiple messages at the same time. But this is just sending me a message at Gmail. And so that's really where it's going at this point. So if I open up my Gmail account, I should see some messages here. I'm probably have to switch accounts here. I think I'm in, here, let me pull this one up. And this is just a Gmail account and brand new messages. These are the 3 messages I was expecting it to get. This one was the one from the upload. This was the movie capture right here from the blob storage. So this is the one that went by the IoT device, uploaded it to blob storage, the event grid topic, then sent the message, responded to that event, and then sent a message up to the service bus, which then sent it over to Logic app. Then it created an email message and sent it to Gmail. This was the one that was directly sent from the IoT hub. So the device sent it to the IoT hub, who forwarded it over to the service bus, which sent it to Logic app that sent me an email address. This one took a more roundabout message. This one went from the IoT this one went from the IoT device to the IoT hub, to the event hub, to storage, over to the event grid topic, back into the service bus, to Logic app, over to an email. So it took a longer roundabout way to get there, but it still ended up in my inbox based on that message route that it took. So the point of all this is that you can create rather complex message routing on Azure, and typically you will end up doing that in your solutions, and you will end up using multiple messaging solutions depending on what your needs are. Again, and just realizing what each one of these is for and how they manifest themselves. Hopefully we've talked about the use cases of each one of these different platforms and what they're used for. But in this case, I try to implement them in their appropriate context so that we can kind of get an idea of the totality of what it is that we're trying to do with messaging on Azure, and how you can use these to shape your applications and your platforms for doing various kinds of things in the Azure context. So again, a very extended demo, and it can kind of get a little confusing, but hopefully you can kind of see how these kind of all kind of come together to create a more robust solution that's not just a single one-size-fits-all for everything on Azure. Rather, you have a bunch of different kinds of solutions that do very different things, but there is a lot of overlap between them as well, as we've seen already. So now that we've kind of gone through that, I do want to answer questions. I think some... So if you want to ask questions, please pose those in the questions box there. You can definitely, let me pop this message feature out here. Let's see if I can get this so I can see these questions here. A lot of questions already. Now the first question was, did you forget webhooks, or are they consideration in Event Hub, an event source that can hook up to a hub? Webhooks are, this is related to, I'm guessing there's actually a couple of different hubs. I'm not really sure what that was in reference to, but actually webhooks are a possibility for any number of these. Event grid topics can do webhooks, and you can use Logic apps with webhooks. Event Hub can do webhooks, and I think even IoT Hub can do webhooks. So it's a supported way. It just wasn't an Azure specific thing. Yeah, but it is a way to integrate things. I love webhooks. I use them all the time for various things. So yes, definitely. Webhooks is definitely a very popular way to allow something to call back into your application or into your context for a number of these different kinds of applications that you can use. And so didn't talk about that much, but yes, you can use webhooks for any number of these things. The next question is, why does IoT device need to send a blob storage in the event of hub and send it to? Is it different info? It's a different use case. Now when we're talking about IoT Hub, IoT Hub has a limit on the size of the message that you can send through it, just like Service Bus does, and event grids and event hubs and storage queues. They have a limit on the size of the message. So a file upload is a very valid use case for IoT devices. So in my context here, it's a movie. It's a movie file. It's probably going to be multiple megabytes in length. It can be dozens of megabytes in length, maybe even 100, depending on the resolution and different things like that for motion capture. And so you can't send that through a service bus, which is ultimately fundamentally what underscores something like IoT Hub. Now, typically with that, you upload that to a storage, and the pattern is typically once you've got that file uploaded to whatever storage is on the cloud, you emit a message saying, hey, I uploaded a file, here's the file name. And that's a different path that responds to it. Now, you could create, like I did here, an event grid topic that responds to something uploaded to a storage account. And that's valid as well. You wouldn't have to do that through IoT Hub. However, it's generally a better practice in IoT workloads to upload it and then say, here's a message, here's the endpoint that I uploaded it to, here's the new file that I uploaded to, and emitted a message that correlates with that particular file upload. That's just more common. However, you can definitely trigger something based on that file upload as well. Say you want to scan for viruses, or you want to process that independent of the message or something like that. Next question was, will the source code be shared? Yeah, I can share that. I'll put it up on GitHub and link it to the YouTube video once we post that. Yeah, I'll definitely share the source code. It's really nothing spectacular. It's mostly just based on a lot of the demos that I did here is based on a lot of the SDK available demos that are out there on Azure that I took them and contextualized them to my needs and then created these little daemons that I wrote. So yeah, sure, I'll upload those to Event Hub. I'll put those on GitHub and then link it to the video once it's up on our YouTube channel. So yeah, share that definitely. Why 3 emails? I'm guessing that's talking about here. In this, the E3 emails. In my demo, I had 3 emails, and that was for 3 different things that happened. In my demo, like I said, for my 3 different emails, I had the IoT device emitted a message, and one of those messages, that message was sent to Service Bus, which sent to Logic App, Sendgrid, Event Hub over here to the email client eventually. Another message went like this. It took a copy of that message, sent it to Event Hub, sent it to blob storage, it persisted it here, that invoked an event grid topic event that sent it back to the Service Bus, and then sent it back down this chain again right here. Then a third one happened from IoT. It uploaded a file which triggered this event grid topic, sent it up to Service Bus, Logic App, Sendgrid, email client over here. So that's why I had 3 messages, because I had essentially a fork of this one right here, and then a third one by way of blob storage. That's why I had 3 email messages rather than 1 message. Okay. Next question. Is there any open telemetry tracing that supports already included out of the box, or any option that you described to do? I'm not familiar with open telemetry, so I can't answer that intelligently. So I don't know. I do know that there are any of the message formats, such as what Event Grid publishes, it's a standard format that says you can pick one of 3 different message formats that it uses for events. Any of these other message types for what originates here or what you put onto a service bus. That is up to you to define. So you can basically put anything on that message. It could be XML, it could be JSON, it could be YAML, it can be just text, whatever. It can be binary data, it doesn't matter. That's up to you to define. So there's really no standard there, but there is a kind of a published standard for event grid messages, but the rest of these are just kind of whatever you want to make it. How long of a lifetime is as a message on Event Hub? It's configurable. You can persist it up to, I think, a week, but it's not advisable. So just because you can do something doesn't mean you should do something. It's not designed for that. Don't use it for that. So yes, you can have a message last on there for up to a week. I think it's configurable to 7 days. You don't want to use Service Event Hub for any kind of long-term persistence, just because it's not designed for that. You'll clog up your Event Hub if you try to do that, because it's designed for massive scale of lots of messages coming into essentially like a funnel, and then kind of streaming that into a processor. And so if you want to persist messages, use Service Bus, and that has a configurable a TTL, a time to live, for every message on that. And I think that one's configurable up to a month, maybe more. I can't remember exactly what the threshold is, but yeah, just because you can do it doesn't mean you should do it. So definitely use Event Hub for streaming and streaming only. Don't use it to persist messages. If you're going to persist messages, do it because your stream processor failed, and you're not going to, and you expect to get that up back and running quickly rather than just in a long term. Okay. Next question is, why is SMTP blocked from Azure on most of the subscriptions? It's probably because it's not trusted, because Azure IP blocks. It's easy to spin up an SMTP server on Azure. Oh, why is it blocked? Azure blocks it. Yes. Azure blocks SMTP messages because you could easily spin up a spam server on Azure, and Azure doesn't want its IP CIDR blocks to get blacklisted so that it can't send any messages. So you typically have to farm that out to something like either Twilio, and Twilio send the messages through Sendgrid, or use O365 or some other SMTP provider. Azure does not support SMTP servers for that very reason, because it doesn't want people creating spam bots on Azure, and that's why they don't do it. Next one is, what do we have to assist us in visualizing the architecture, graphically mapping and drilling down, and to summarize, how do we summarize the resource commitments? That's a good question. Every one of these different services has a different way of monitoring it, and they have different metering metrics that they use for processing. Like Event Hub is typically done by message batch sizes, and while something like a storage queue is basically on the amount of storage plus the number of operations. Service Bus, it's a combination of compute plus message telemetry, and so on. So how do you summarize resource commitment? You can monitor it, and then you can use something like the Azure calculator to kind of get a cost of what each one of these, because they each have a different billing model that's associated with them. But you would have to kind of understand the billing model of each one of these in order to get a full scope and scale of how you want to understand the resource commitment, and then also pick the tier that's going to be appropriate for your application. Now, for my demo, this is very minimal, so I basically just set it to the lowest threshold that I could. But if in a real-world application, you're going to have to tune these each to the appropriate summary that you're going to have there. So that's kind of what we're looking at there. Let's see. Could this demo architecture be deployed by a CI/CD pipeline as infrastructure as code? Absolutely. It can be deployed as infrastructure as code. Everything I did here is reducible to ARM templates. And so you can basically take all of this, create an ARM template, create a Terraform template, do whatever, put that in your repository, and then deploy it as code. So yes, you can configure IoT Hub. You can configure Event Hub, blob storage, Event Grid, storage queues, Service Bus, Logic Apps. Logic Apps, you might have to do a separate deployment to get the code onto the Logic Apps, but still, you can deploy Logic Apps and then do that. It's got a code repository, even though it's a visual designer, you can still get the code export and then put that as part of your repository. The only thing that you might not be able to do is a Sendgrid, but the configuration, the integration with logic apps you could do by way of infrastructure as code. That's got an API, so you could actually do it through infrastructure as code, but anything on Azure you definitely could do. These daemons are Node.js code, so yeah, you could deploy that as IoT. Obviously, you can't deploy a device through IoT. You can't deploy a physical device through CI/CD, but you can definitely deploy to a device through CI/CD, but it would have to be brokered by way of probably an IoT hub or something like that. So yes, definitely. How would you kick off logging in Event Hub? How would you kick off logging from Event Hub and Event Grid topics? I'm not sure I understand the question as much. You can monitor both of those, and you can monitor both of them for throughput. It's not going to log all the messages per se, unless you're doing some kind of persistence like this, like I have here. And logging, you can monitor Event Grid topics as well using Azure Monitor as well as Event Hub. And many times, and so yeah, you can monitor them in that context and log them in that manner. But in other contexts, they can also be part of logging solutions. So logging is sometimes what you might be sending into an Event Hub. So if you have a lot of log aggregation that you need to do and you need to funnel that into some kind of channel to process that in real time, Event Hub would be a way to aggregate logs into a single channel and then pump that through some kind of system that can process it, such as Stream Analytics or Kafka or what have you. Event Hub would be the source for doing that. And Event Grid topics is useful for doing logging on Azure. So if you want to subscribe to all these events, you can set up a bunch of Event Grid topics and then persist those in storage queues or blob storage. You can send them through a service bus, Event Grids, what have you, as a subscription in that manner as well. Another question here is Web Pub Sub is processing. Will you talk about it? Web Pub Sub. I'm guessing that would actually be what Signalr is Web Pub Sub is. Is that a specific? I'm familiar with if that's a specific technology. I don't know if that is, but kind of. Okay, based on Signalr. Yes, I did talk about Signalr. I didn't do a demo on that because I didn't have the time to kind of get a demo together, but the Signalr is Web Pub Sub, but you could do that easily through integration points with your application. So you could put a Signalr client and wire up something like a service bus to send messages through that, and then vice versa. You could have that wire up messages to pull messages off that Signalr to respond to it as well. And so that is how you would use a Web Pub Sub model in this context. But you would definitely want to broker that by way of a web app, because it requires that you have a web app to broker the Signalr connection. But once the Signalr connection has been brokered through the web app, then it's set up between the client and the server, or the Signalr service, and you can send that back and forth bi-directional communication between the app, servers to app, and then app back to server in that context. So yes, you can do that. I don't. Okay, so somebody did talk about Web Pub Sub on the service. I did not mention that. Unfortunately, I'm not familiar with that. I haven't looked into that, but that's good. I need to probably look into that because I've heard it mentioned before. Signalr has just been the more traditional approach, but Web Pub Sub is something I need to skill up on. I just don't know. So, but I would have to look at it and see what that is. So thanks for that link. I'll definitely look into that. Is there any other appropriate tools besides Stream Analytics, multiple outputs, to route different types of messages to that are for different handlers from a single Event Hub? Stream Analytics is one of them. You can do Azure Functions. You can use Kafka. Kafka is part of HD Insights. So you can have HD Insights on Azure is basically the Hadoop ecosystem that allows you to have, all things, Hadoop, which would be like Pig and Flume and Kafka and what is that one called? I'm drawing a blank here. It's what Databricks is blank based on Spark. That's what it's called, Spark, and all of those kinds of services associated with it. And you can use anything like Kafka on HD Inside or a standalone Kafka instance or something like that in conjunction with Event Hub to process messages. So Stream Analytics is just the one that's kind of the out-of-box experience for it. It's very easy to use, set up, and configure. But if you want to go and do a full investment into Kafka, you can do that with HD Insights. Or if you want to create a Kafka cluster, self-manage it, on a set of VMs, you can do that. Or if you want to configure Databricks to do something like that, you could definitely do that as well. Although Databricks is typically more oriented towards batch processing, you can do streaming with it. It's just it is possible to do streaming, even though it's more oriented around that more batch style processing. So those are possible solutions for Event Hub. So it's there's a lot there that you can do, and you can kind of roll your own if you want to. It supports open protocols, so it's not you're not restricted to those. So if you want to implement the subscriber protocol or do what I did here in this Node.js application and use the SDK to roll something yourself that processes events as they come off the Event Hub. And I use Node.js, and I could put that on a VM, a Docker container, or something like that, and then process, or I could use Azure container instances and process data that way. So again, there's a lot of options that you can do in that context. So lots of possible solutions for Event Hubs. So I think that's the last question. So we're a little bit over, but thanks for bearing with me on this. I know that we went a little over, but thanks again for bearing with me on this. It's been hopefully this has been informative for you guys, and you've had a lot of good questions, and hopefully you kind of got a lay of the land for all the messaging options on Azure. There's a lot of them, and just trying to make sense of them all can be a little bit daunting. And hopefully this will give you some context for that, and you can help orient you and get you started on exploring these different options and then integrating them with your own applications and solutions on Azure. So we'll be posting this again to our YouTube channel. Feel free to reach out to me online, and we'll definitely be available for questions if you want to email me. I'm blaze.stewart@amacera.com, or you can reach me on the One Mule on Twitter as well. So thanks for coming, and look forward to seeing you guys on future Wintellect or / Amacera webinars now.